Part of chemistry, as based off the definition of what chemistry is the study of transformations. Transformations is the change that occurs from one substance becoming a different substance. In order to understand how those transformations take place, we need to understand properties of matter. When looking at properties of matter, there are two categories, physical and chemical. Physical means we can observe these properties, we can measure these properties without changing the compound or the substance in which we are working with. Whereas chemical properties means that what it's interacting with, these properties, means it can be changed when exposed to those specific properties. A good way to visualize this is a flow chart, and looking at this basic question is, the properties we are observing, can they be determined without changing the identity or the composition of that substance? If it is yes, then that is going to be a physical property because the identity is going to stay the same. So once we've identified we're going to be looking at physical properties, then we want to look at, well, the amount matters. If we are identifying the color, the melting point, the boiling point, or the density, those are called intensive physical properties. They don't change based off the amount of the substance we are looking at. So one like shaved ice cube versus a big block ice cube, they're going to have those same properties no matter what. Extensive properties, however, do matter with the amount. So it's mass, volume, length, shape. All right, so we have those physical properties, but in chemistry, what we really like to talk about are the chemical properties with these ideas of transformation. When a chemical compound undergoes a transformation, it's changing from the substance to something new. It has to do this upon interacting with something. Does it react in the presence of? Because you need to have that presence to allow the transformation to occur. Will it react with air, acid, base, water, other chemicals, energy? These are all different types of chemical properties. This can give us ideas about its toxicity, its reactivity, because those are going to be the properties that interact with a system. So if something's really toxic, it could be interacting with the acid or the base in a system, changing the way that system works. Once we've identified those the properties of matter, we can then identify changes. A physical change means the composition is going to stay the same. We're just going to do something. Example being in these graphics that I've made, we are breaking the egg. The eggshell's still there. It's just in smaller pieces. Changing the state of matter, going from an ice to a liquid to a gas. They're all the same substance, they're just spreading apart. Changing the size by shredding, folding, chopping, still the same compound. Mixing paints, you have those individual color properties just mixing together. Whereas chemical properties, this is where that new substance is formed. What we're doing is what's called atom rearrangement. And when we are performing these reactions, we call them human rearranged molecules. What we start with is going to be different than what we end with. Examples include rusting. So iron, we have iron, and when it gets exposed to oxygen, it can rust. It's now iron oxide. Burning takes your hydrocarbon, your oxygen, creates CO2 and water. Cooking and baking causes chemical reactions to occur between the substances within there. Ripening to rotting, fireworks, acid-base reactions, these are all what we start with is not the same thing as we end with, and those are those chemical changes. And that's what this next unit is going to be focusing on.